Okay, difference quotient. The difference quotient is a concept that is heavily used in calculus. However, we talk about it here because we use the difference quotient in order to find the slope of a curved line. It's called the slope of a scant line, or secant line. A secant line is a line that is used when your graph is not quite linear. And we can use this idea, it's the idea of the slope, in order to actually determine different things about whatever that line was, or that graph, or those functions. So if you remember, your slope formula is the change in y over change in x. Well, your difference quotient formula is going to be this here, where we are going to have the function of x plus h minus the function at x, and then all over the h value. So this right here is the difference quotient formula. And the formula stays the same no matter what. The only thing that's going to change is the functions we've been given. So what you're going to notice about these problems is that you are only ever going to be given f of x. To find the difference quotient, we need x plus h. So you have to create it. So the very first thing that we have to do is you have to create f of x plus h. So to do that says that we are going to have f of x plus h. When anywhere I have an x, I have to input x plus h. So this becomes 5 times x plus h squared plus 4 times x plus h. So I have to go ahead and expand this out. So this is going to be 5 times x squared plus 2xh plus h squared. So if you want to know how we did that, we FOIL this together because the 2 here tells me I have 2 of them. And then this is going to be plus a 4x plus 4h. Distribute that 5 through, and we have 5x squared plus 10xh plus 5h squared plus a 4x plus my 4h. Once we've created x plus h, the second thing that we have to do is we have to apply the difference quotient formula. So that formula says f of x plus h minus my f of x all over h. So here we are going to have 5x squared plus that 10xh plus the 5h squared plus that 4x plus the 4h. We are going to subtract away that 5x squared plus the 4x, and then we are going to divide this whole thing by h. So here, the first thing we need to remember is that this negative has to be distributed through the back part of my parentheses. And so here we've got 5x squared plus the 10xh plus the 5h squared plus that 4x plus the 4h minus the 5x squared minus 4x. And this whole thing here is all over h. Now again, just like before, I have some like terms, so I've got the 5x squared and a negative 5x squared, so these are going to cancel out. I then have a 4x and a negative 4x, so these are going to cancel out. And what you should notice is that the only thing that's left behind are h terms. As long as that's the case, then chances are you've probably done it correctly. So here, this is going to end up with 10xh plus 5h squared plus 4h. The whole thing is over h. Notice I can cancel an h out, so I can cancel it out of the top. I can cancel one out from here. I can cancel it out here and cancel it with the bottom, which is going to leave me with 10x plus 5h plus 4. And this was my difference quotient. Alright, let's try one more here. So here I want to find the difference quotient for the following function, 3 over x. So in this one, we're essentially working with fractions. So again, the first thing that we have to find is f of x plus h. So here, this is going to be 3 over x plus h. And in this case, there's nothing else to do. That second step says we have to apply the formula. So 3 over x plus h minus 3 over x, and the whole thing is over h. So let's start in and see what happens. So here, the first thing that we have to do is we have to follow our fraction rules. So here we have to remember that to combine your fractions, you need a common denominator. So I have 3 over x plus h minus 3 over x. So here, my lowest common denominator is going to be x times the x plus h. So when I'm looking at it, in my first term, I'm missing an x, so this becomes a 3x on top. My entire denominator is going to be x times x plus h. Now on the other side, I'm missing the x plus h, so this is minus 3 times x plus h. And thus I have a common denominator. So here I'm now going to have my 3x minus 3x times, or 3x, hang on, let me write that again, sorry about that. This is going to be that 3x minus 3 times x plus h all over x times x plus h, and the whole thing is over my h term. So don't forget, it's got its own big denominator. Now, continuing to work with this top, we can take this negative 3 piece and we can distribute it through, thus making this 3x minus 3x minus 3h. This is over x times x plus h, and the whole thing is over h. Now, when we're looking at that, 3x minus 3x is going to go away. So here, this is going to leave us with a negative 3h over x times x plus h, and the whole thing is over h. Now, when we're dealing with fractions, there's another rule we have to keep in mind, and that rule says when we have fraction over fraction, we need to keep the top, change to multiplication, and then flip the reciprocal of the bottom. So here we're going to keep the top, so that's 3h over x times x plus h. We're going to change to multiplication, and we're going to flip the reciprocal of the bottom, so we turn it into 1 over h. Now if you're paying attention, or you look, you can see that the h's are going to cancel. So this is going to leave us here with negative 3 over x times x plus h. And that is your difference quotient. So this right here is what we were looking for. Okay. So there you have it. You have a polynomial example and you have a rational example, both of which are used, or both of which show having to find the difference quotient. The biggest thing that you have to remember there is that the difference quotient is a take on the slope. And the thing that you have to do first is you need to find or create your f of x plus h term. So if you have any questions, please let me know. Otherwise, I will see you next time.